Hi friends, have you ever visited these kind of humongous buildings such as the Eiffel Tower, Statue of Liberty, and Empire State Building? Or have you ever visited these kind of gigantic waterfalls such as Niagara Falls, or have you seen more? Well, if you go too close to them, did you ever get a good view? Take the Eiffel Tower, for example. If you go to the bottom of it, or if you go too close, you cannot really get a good view. So you have to stay away from it. Similarly, if you want to see our own planet, or you want to do any researches such as climate research, weather forecasting, or navigation, you have to step out of our own planet. Stepping out of our own planet will give you a better understanding of our own planet. What's essential to step out of our own planet? You got it. Yes, it's a rocket. Hi everyone, my name is Ashrita, and today's topic is on how rockets work. And the people who subscribed, thank you a lot. The people who didn't, please subscribe, share, and like. Before going into the real topic of how rockets work, let's learn about how rockets were initiated. The mighty rockets of which we see today have been the result of 2,000 years of continuous experimentations, inventions, and discoveries. A Greek philosopher had created a bird-shaped device which is propelled by a jet of steam. And this is the first reported device that uses a jet of steam. Gunpowder. Gunpowder was invented by the Chinese, and they used a mixture of saltpeter, sulfur, and charcoal dust, which produced colorful sparks and black smoke when ignited. And yes, these were used as fireworks. Later on, these fireworks were used as weapons for war, and largely by Tipu Sultan, India, to fight against the British. Galileo had invented the concept of inertia, which is later followed by Sir Isaac Newton, and thus the birth of rocket science has begun, and also space age began. Now let's get into the topic of how the rocket works. Before rocket launching, the ground begins to rumble. The massive engines start to roar. Billowing clouds of dust begin to form. The countdown starts. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off! The mighty Voyager enters into space. How? There are many different types of rockets based on purpose and distance, but almost all of them are propelled by thrust. What's thrust? Thrust is basically a force which moves a rocket in the air and in space. Every rocket works based on Newton's third law, which is every action has an equal and opposite reaction. Everybody thinks that the engines bring the rocket up into space, but no! Actually, the thrust will push the ground very hardly. This is the action. And the reaction is nothing but liftoff. Now let us get into the topic of the parts of the rocket. This whole rocket is covered by thermal protection, and this thermal protection protects them from extreme cold and hot conditions in space. Now let's get into the topic. The first part of the rocket is the payload system. The payload system includes the cargo, astronauts, missiles, and even satellite. So, to say it in simpler words, this part basically holds the things that are supposed to go into orbit. Next, guidance system. The guidance system includes all the sensors, radars, onboard computers, and more. This is like a tracking device. Next, propulsion system. Propulsion system is basically like 70% of the total rocket. And this part brings the payload and the guidance system up into space. There's two tanks, fuel and oxidizer. Let's start with fuel. Fuel can be any type, such as kerosene and more. Next, oxidizer. Oxidizer is nothing but liquid oxygen. Both the full fuel tank and the oxidizer have a pipe which is attached to it. And at rocket launching, the fuel and the oxidizer gets collected by the pipes and mixed into a chamber named the combustion chamber. And the combustion chamber mixes the fuel and oxidizer into a particular ratio, and thus creates a big fire and liftoff. But there is one thing to consider. Pretend this is Earth. 250 miles above it, there is a gravitational pull named the Earth's atmosphere. And this Earth's atmosphere has a lot of gravity that nothing can escape from it. So, to escape from it, the rocket needs a lot of force. So, if it needs more force, it needs more fuel. Where would it get all that fuel from? This is why there are boosters attached to the rocket. Oh, do you remember that in my first video, I told about boosters? And didn't I say that when the boosters are empty, it gets separated and it falls back onto ocean? This is what we're talking about now. Staging. Staging is the separation of one engine. And when one engine is separated, the next engine immediately starts to work. So this staging will keep on going until the satellite, which is inside the payload system, goes into the particular orbit which is desired. And you might be asking, well, how many stages there might be? There might be 2, 3, 4, or 5 stages. And it depends on the purpose and distance of the rocket. Suppose the rocket's going to Mars. Well, it'll need a lot of stages. Pretend Moon. Well, for Moon, it needs a few stages. And even ISS also, it needs a few. Now let's discuss about some facts. Before rocket launching, the rocket sits on the launch pad. The ground begins to tremble. The massive rockets start to roar. But there's a technical issue. So due to that, the whole rocket burns up, including the astronauts in it. All the astronauts burned in spot and died. This is what happened to a couple of Apollo projects. Another example, take Space Shuttle Columbia. While returning back to Earth, there was a technical issue, and due to that, the whole space shuttle burned up, including Kalpana Chawla and the 6 crew members with her. This was a sad incident for NASA and a great loss. So to prevent this, engineers had come up with the idea of LAS or LES, which stands for Launch Abort System, or you can call it as Launch Escape System. Like if the rocket has any technical issue, the LAS will immediately detach the payload system, since it is the most important part. It'll detach the payload system and bring it back safely down to Earth. Even though NASA had lost the rocket, at least the payload system is safe because it has all the most important piece and the astronauts. Saturn V. Saturn V, you might be thinking what that is. And Saturn V is the rocket which carried Neil Armstrong and Buzz Aldrin up onto the moon. And Saturn V is the rocket which is used in all of the Apollo projects, which are moon projects. Did you know that Saturn V carried 5 million gallons of fuel and oxidizer? Imagine how high it is. Saturn V is high as a 36-story building. Now what's the weight then? Get ready. The weight is equal to 400 elephants. Now that's a lot. If you visit NASA, be sure to visit Saturn V. It's right there. Did you know that escaping the Earth's atmosphere will only take 3 minutes? Imagine how fast it goes. And our last point is that a rocket wouldn't go straight forward or it wouldn't go horizontally. It goes straight and then it takes a little turn, which is slanted or laterally. Why does it do that? It has 2 benefits. 1, it saves more fuel. 2, it will prevent aerodynamic stress. Wow, what is that, you might be thinking? Aerodynamic stress is basically the air pressure. So like if the rocket goes straight, then there'll be a lot of air pressure. If the rocket goes slanted or laterally, there'll be less air pressure to worry about. And that too will save more fuel. And this is it, everybody. So please subscribe my channel, like. Also, if you have any other points to add on, please do it. This is Ashrita signing off.